Good evening. Today we're going to talk about the formal definition of a limit. Suppose we have the limit as x approaching a of f of x, which is equals to L. So how can we use precise definition of a limit? Precise definition of a limit to explain that. How can you must say, write the first definition, said what? For all delta greater than 0 they exist epsilon greater than 0 such that what? X minus a is less than epsilon but greater than 0. This a is any value can be there, and this x is this one. Understand? Then f of x minus L is less than delta. This implies that f of x minus L is less than delta. Our goal is to always find what? X minus a. This is our everyday goal. Our everyday goal is to find this. Understand? That's how a precise definition of a limit works. So let's do some few examples to see if you understand this chapter. So suppose you have the limit as x approaching 2 of 2x plus 1. They say use precise definition of a limit, or use formal definition of a limit, or show this thing equals to this using precise definition of a limit. First step, you are going to do what? You are going to substitute your what? You are going to substitute your value of 2. You are going to have 2 into 2 plus 1, which gives you what? 4 plus 1, which equals to 5. Meaning this thing means that the limit, they are saying, show that the limit as x approaches 2 of 2x plus 1 is indeed equal to 5. So first step is to what? Write the definition. Understand? So the definition is going to be like this. For every delta greater than 0, they exist epsilon greater than 0, such that what? Such that x minus a, what is our a now? Is 2. X minus 2 is less than epsilon but greater than 0. Then what? The absolute value of f of x, our f of x is what? Is 2x plus 1 minus L. Our L is what? Our L is 5. Suppose you are following this definition. Understand? It's less than what? It's less than delta. This thing does what? This thing implies what? Implies that 2x plus 1 minus 5 is less than delta. Remember, our goal is to find what? Our goal is to find x minus a, which is x minus 2 at this case. This is our goal now. So our goal now, we are forced to find what? We are forced to find this. Understand? So let's find that. So this thing implies that 2x plus 1 minus 5 is less than delta. And this thing implies that 1 minus 5, which is negative 4, 2x minus 4 is less than what? Is less than delta. Understand? You want x minus 2 is your goal. How can you find x minus 2? Understand? The only way to find this thing, x minus 2, is to do what? Is to remove a common factor of what? Of 2. So let's remove the common factor of 2 and see what's our answer. This thing implies that 2 into x minus 2 is a common factor, is less than delta. Understand? Bear in mind that the absolute value of A multiplied by B equals to the absolute value of A multiplied by the absolute value of B. Understand? So we're going to apply that here. We are going to apply it here. Understand? This is our A here. This is our B here. This is our multiplication. Ne? So let's move on and find all that they want there. So it means you are going to say we have the absolute value of 2 multiplied by the absolute value of x minus 2 is less than what? Is less than delta. Understand? So our goal is to find what? Our goal is to find x minus 2. Here is x minus 2. Understand? So let's find it. So you know, if you press your calculator at the bottom of shift, there is this thing written ABS. Understand? If you press that ABS on your calculator and substitute the absolute value, you're gonna see the absolute value and substitute the value of 2. You're gonna get 2 multiplied by x minus 2. Absolute value means strongly 0. The absolute value of negative 1, if you press it on your calculator, equals to 1. The absolute value of negative 2, if you press it on your calculator, equals to 2. The absolute value of 2 equals to 2. Absolute value means everything is positive, is strongly positive. Understand? So here our goal is to find what? X minus 2. So it means I'm going to divide both sides by 2. Ne? Therefore, I'm going to have x minus 2 is less than delta over 2. So when you reach this point, you are going to choose now. Ne? You are going to choose or guess. You are going to choose what? You are going to choose that what? Epsilon equals to delta over 2. Understand? You are going to choose this. You are going to choose this equals to with our delta, our epsilon equals to that. Ne? The last point you are going to say what? You are going to say epsilon equals to mean from where? Mean from 1 to e over 2. That's how you can show that. Let's try another example. Let's check this one. Suppose they say what? They say this example number 2. They say show that the limit Sx approaching what can I say? Sx approaching 1 of what? Of x plus 1 ne? Equals to 2. They say use formal definition of a limit. How can you do that? Ne? So do this question on yourself, applying that formula. Understand? And see if you understand. For now, let's go on. You are going to write the definition. Say for every delta greater than 0, they exist what? They exist epsilon greater than 0. Such that what? Such that x minus a, our a is 1 now, x minus 1 is less than epsilon but greater than 0. Then what? Then our f of x, which is x plus 1 minus L, which is 2 for now, 2 is less than delta. This thing implies that x plus 1 minus 2 is less than delta. This implies that what? This thing implies that x plus 1 minus 2 is less than delta. Implies that 1 minus 2 is negative 1. We have x minus 1 is less than delta. Our goal is to find what? Our goal is each and every time our goal is to find x minus a, which is x minus 1. So in this case we have x minus 1 in its state. Understand? So now we are done. We're going to do what? For now we're going to choose. We're going to choose or guess. We're going to choose that delta equals to epsilon. Epsilon equals to delta. Therefore we're going to have a mean from where? Mean from 1 to our delta, or our epsilon, which is equals to e over something. Can say over 1, still fine. Understand? So let's check another question. Question number 3 is the lim as x approaching 1 of what? I can say of x squared equals to 1. They are saying use formal definition of a limit to show that. The first step is to what? Is to insert that value they are telling you about. 1 squared equals to 1 is indeed true. Ne? Therefore, you are going to apply the formula, the definition. Say for all delta greater than 0, they exist epsilon greater than 0, such that x minus a, understand, x minus a is less than what? Is less than epsilon but greater than 0. Then what? Then f of x, the absolute value of f of x, which is x squared, minus l which is 1, is less than delta. Understand? This thing implies that what? X squared minus 1 is less than delta. Bear in mind we still have our algebraic expression of a squared minus b squared. This thing is a difference between two squares of a plus b and then a minus b. Understand? So what is our goal? Ne? Let's write our goal in this blue, kind of like purple. Our goal is to always find what? Our goal is to find a x minus a, which is now here x minus what? X minus a. Yeah, we're supposed to put 1 here. Sorry, I made a mistake. We're supposed to put 1 there. I was thinking of a. So we're supposed to put 1 here, which is this one. Understand? So our goal is to find that. Our goal is to find x minus 1. Let me write my goal on that side. Our goal is to find x minus 1. This is our goal. We have to find that. So let's continue. This thing implies that what? X minus 1 into x plus 1 is less than delta. So I told you the absolute value of a multiplied by b equals to the absolute value of a multiplied by the absolute value of b. So with that case, we are going to apply this here. Understand? Meaning we are going to have the absolute value of x minus 1 and the absolute value of x plus 1. Remember, our goal is to find the absolute value of x minus 1, not x minus 1, the absolute value of it. Meaning our goal now is to find what? Is to find this. If we had a value here, we were going to divide by it. Since we don't have a value, we're going to deal with it now. Ne? Let's take that thing. I want to show you how to get the value of this thing. Ne? Let's see. You are going to say x. You're going to say x plus 1. Understand? So we have x plus 1. Ne? So since we are approaching what? We are approaching this one. Ne? So you are going to draw a number line. You are going to draw a number line like this. Your beautiful number line. Then you put your 1 here. So after that, you look at the values that are closer to 1 from the left and from the right side of 1. Ne? So it means in this case, I will have my 0 here. I will have my 0 here, and I will have my 2 here. It's not always you have to choose 0 or 1. You just choose any number you want closer to 1. But then let's choose these numbers, because this one are integers. Ne? Let's choose the integers so that we can have a clean work. Ne? You can still take 0.5 here and 1.5. It's still closer to what? To 1. But let's take these integers, since they are really integers and they can make our work really clean. Ne? So now let's start. So I'm going to do what? This thing is like this. Suppose we have a function goes like this. Ne? This function goes like this, straight like this. Understand? Sorry. This function goes like this. And this function at x equals to 1 has a hole here. Understand? This means what? This means this thing is not defined there. We have a hole. Ne? So how can one find how can we find the values of what? The values of f of x. We want, this thing is your f of x, remember, is your f of x. How can we find the values there? Understand? The question is that, how can I find the value here? Since, well, this thing is not defined, you cannot substitute 1, ne? But what can you do? The only thing that you can do is to find what is the value of x in the upper bound, of f of x in the upper bound here. Meaning this here, this part, ne? Since, well, is defined here, ne? And also here, at 0, you must find what is the what? The value of f of x. So if you have the values of x here, understand, and you have the values of x here, which means your values of x, that the one that you want here, the one that we want here is between this value and this value, ne? So we are approximately closer to it. Understand? So how can you find that thing? First step is to what? Is to know that my interval is within this range. My interval is within this range. Understand? That's my interval. It's this side. This side, ne? Is between, we want to know, ne? It means my interval is greater or equal to 0 but less or equal to 2. It means I'm talking about this number and other numbers. Understand? It's included there. Understand? So I'm going to check the value of what? The value of my function, which is x plus 1. At x equals to 0. What is the value of my function value? So it means I'm going to substitute my value 0 plus 1. So my function value is what? Is 1. And I'm going to check again at x equals to 2. It means I'm going to have the absolute value of 2 plus 1, which equals to 3. Understand? This thing means what? This thing means what? This means here is 3 and here is what? I mean, there is 1, sorry. At x equals to 0 is 1. At x, let me write this on this thing so that it can be clear. This thing means at x equals to 1, ne? At x equals to 0 actually is 1, ne? At x equals to 2 is what? Is 3. But the thing that we want is here. Whatever we want is here, ne? So it means whatever we want is between 3 and 1, ne? So if it's between 3 and 1, what can we do? We know this is our interval that we choose. The one of x is less or equal to 2 but greater or equal to 0 is our interval, is the values of x. So the values of x plus 1 are where? Are less than y and greater than y. We know this thing here, the one we want, the values of x that we got, and then the answer that we want here is between what? Is between the values of f of x is between 1 and 3, but is greater than what? Is greater than what? Than 1. Ne? This thing is greater than 1, but is less than 3. It means this thing is less than what? Is less than 3, but greater than what? Greater than 1. So that formula that was saying implies that x minus 1, the absolute value of x plus 1 is less than delta. So we want something that is less than delta. Understand? Less than this thing, this smallest value here. We want the value. Because if you say you put your answer here as what? As 1. You are telling them the what? You are telling them that your value is less than what? Is less than 1. It means you are referring to this part, which you are wrong. But if you say it's less than 3, it means you are referring here, and you are including this point that they want. It means you are right. We are going to take what? X equals to what? 3. We are going to substitute it. It means x minus 1, absolute value of 3 is less than delta. Understand? So in this case, you press your calculator. You know the absolute value of 3 is 3 minus 1 is less than delta. So our goal is to find what? Remember, our goal is yet to find what? Is to find x minus 1. So let's find our x minus 1. Then simple stuff. We're going to divide both sides by 3. Therefore, the absolute value of x minus 1 is less than delta over 3. So now we are going to choose. We are going to choose what? We are going to choose that epsilon equals to delta over 3. Always, all the time, you choose that. You choose this equals to epsilon. Ne? Therefore, you're going to say your epsilon equals to your minimum from 1 to epsilon over 3. That's your final answer. This is your final answer. You got your marks and you leave. Understand? So now let's check another part, another hardest one. You're going to check the limit Sx approaching I can say what can I say? Sx approaching 1 of x cubed equals to 1. First thing first, you have to confirm that thing is true, ne? So it means you're going to have what? 1 cubed equals to 1. This is your 1 mark, ne? Therefore, you say what? You say the limit Sx approaching 1 of x cubed equals to 1. Understand? So after that, you write your definition. You say what? For every delta greater than 0, they exist what? They exist epsilon greater than 0, such that x minus a. Remember that formula is like this. We have the limit Sx approaching a of f of x equals to L. We say for every epsilon greater than 0, they exist epsilon greater than 0, this thing, that one is a delta. Understand? They exist epsilon greater than 0 such that what? X minus a is less than what? Is less than epsilon but greater than 0. Then what? Then f of x minus L, this L, is less than delta. This thing implies that f of x minus L is less than delta. Your goal is to always find what? Is to find this thing here. Understand? So the last part you are going to say what? You are going to choose. The last part you are going to choose. You're going to choose that epsilon equals to delta over any number here that you will have divided by 8. Understand? Therefore, final answer goes to be epsilon equals to the mean from 1 to epsilon delta over any number that you divided by 8. Ne? So in this case, we have x minus a. Our a is 1. It's 1. Then it's less than what? It's less than what's this thing called? So called it's less than epsilon but greater than what? But greater than 0. Then what? Our f of x, which is x cubed, minus our L, which is 1, is less than delta. That thing implies that x cubed minus 1 is less than delta. You see, now you are going to apply the algebraic formula. You know a cubed minus b cubed equals to what? Equals to a minus b into a squared plus b squared plus a multiplied by b. Understand? So remember, 1 is the same as 1 cubed. Understand? So it means your a equals to x, your b equals to 1. So you are going to what? You are going to take this and apply it here. Understand? You are going to apply that. Simple stuff. Therefore, you're going to say what? This thing implies that what? X a minus b, which is what? X minus 1. X minus 1 into a squared, which is x. You say x squared, b squared, which is what? B squared, which is what? Which is 1. You're going to have what? You're going to have 1 squared is the same as 1 plus a multiplied by b, meaning x multiplied by 1, which we're going to get what? You are still going to get x. Absolute value less than delta. Ne? Remember, the absolute value of A multiplied by the absolute value of B equals to the absolute value of A multiplied by the absolute value of B. Understand? This thing implies what? This thing implies that what? You are going to treat this thing as A here, treat this thing as B, treat this part as this dot, which is the multiplication. Ne? We're going to have x minus 1, absolute value of x squared plus x plus 1 is less than delta. Ne? So what is our goal? Don't forget. Ne? What is our goal? Our goal is to find x minus 1. Don't forget. Or my goal, always, all the time. My goal is to what? My goal is to find x minus a. For now, my x minus a is x minus 1. This is my goal. No matter what, I must find this from here, which is this one. If I had a value here, I was going to divide by it. Ne? So since I don't have a value, let's approximate it. Let's create it. Ne? So we have our function, the absolute value of a squared, x squared of x plus 1. So we know we are going to draw a number line. Ne? We are going to draw a number line. That number line will assist us to get what? To get the values. So we are checking what are you approaching. You are approaching what? 1. Ne? Meaning you have to what? You have to put your 1 here. You put your 1 here. Therefore, check the numbers that are on the right. Any number that is on the right of 1 and on the left of 1. On the right of 1 is this side. On the left of 1 is this side. Ne? So this side we're going to have 0. This side we're going to have 2. You can still take what? 0.5 and 1.5 is still fine. Ne? Now I like to take the integers because they are simple to work with. Understand? So we are going to have our graph here. Understand? That graph here has a what? Has a hole here, which means it's discontinuous there. It's not continuous here. Ne? So we have to approximate the value of what? Let me write it like this. We have to approximate the value of what? The values of f of x. Ne? So since here we don't know what is it here, we are going to approximate it. Ne? It means that thing it will go like this. Like this. Here and here. We're going to approximate it using the values that are closer to it. It means we're going to be closer to it from the left and from the right. Understand? It's our trick. So we want to know what is the function value here and here. Ne? So after we got the function value, meaning our answer is between those two numbers, which is here. Understand? So let's check. Our interval is within which one? Our interval is within this range. Ne? Our interval is when x is greater or equal to 0 or less or equal to 0. Meaning I'm talking about what? I'm talking about this part. Understand? So since I'm talking about that part, I'm gonna say what? I'm gonna look the values of f of x, which is this thing I have here. At where? At x equals to 0 and where? And at x equals to, oh, sorry. Here is what? Here is 2. Sorry, I made a mistake. Here is 2. It's greater than 0 going there, but less than 2. Ne? We're going to check at x equals to 0 and at x equals to 2. Our function is this one. Ne? So we're going to substitute 0 there. We're going to have 0 squared plus 0 plus 1 equals to 1. I did not do this thing. Let me check. I think I did it. Oh, it's not that one. It's another one. Yeah. Thanks God. Ne? Therefore, let's check at x equals to 2. We're going to have 2 squared plus 2 plus 1, which equals to 7. It means here we have what? We have the value of f of x, which is 1. Here we have what? Here we have 7. Meaning our answer is here. Is here. Is between what? is between 7 and what? And 1. Ne? Meaning what? Meaning our function, that function of x squared plus x plus 1 is what? Is between what? Is between what? Is less than what? This thing here is less than what? Is less than 7 but greater than what? But greater than 1. It's less than 7 but greater than 1. So remember, going here, continuing with our thing, what were we saying? We were saying this thing implies that what? X minus 1, which is our goal. We want to find it. Then we have a squared plus x plus 1. We created the values. So which one to pick? If you put 1 here, you are telling them that 1 is less than what? Epsilon. Ne? But then it's not true. Because 1, if you say 1 is less than epsilon, you are telling them this is your epsilon. Ne? You are telling them this thing is here. It means you are wrong. But if you tell them that thing is less than 7, you are correct. Because you are also including whatever they want here. Understand? So we are going to pick 7. We're going to say implies that absolute value of x minus 1. Therefore, we take 7 less than delta. This thing is the same as 7 multiplied by x minus 1 is less than delta. You divide both sides by 7. By 7. You remain with the absolute value of x minus 1 is less than delta over 7. Ne? Remember, we got our goal. Is what we wanted. Our goal. We find it. We find it here. This was our goal. It was to find that. Understand? So continuing, we are going to choose that what epsilon equals to what? Delta over 7. Ne? So you say epsilon equals to what? The mean from where? From 1 to delta over 7. They can give you the value of delta on the question and say delta equals to 0.005. So you are going to substitute that thing here. Ne? You are going to substitute it. If they give you, if and only if they give you, you are going to remain with what? With 0.005 all divided by what? All divided by 7. Therefore, you press your calculator there, you get your answer. Understand? That's how you treat that thing. Ne? It's very simple, nice and simple. So let's check another one. Another one is when the limit Sx approaching 24 of square root of x plus 1, they say equals to 5. First step is to prove indeed they are right before you start solving. You have 24 plus 1, which is indeed equal to 5. Therefore, it means the limit Sx approaching what? Sx approaching 24 of square root of x plus 1 equals to 5. You're going to write the definition. For all delta greater than 0, there exists epsilon greater than 0, such that what? Such that x minus a, which is x minus 24, is less than what? Is less than epsilon but greater than 0. Then what? Then this. Then f of x, which is square root of x plus 1 minus L, which is 5, is less than delta. You are going to get your free mark from finding this and using the definition. Ne? So let's go on. This thing implies that the absolute value of square root of x plus 1 minus 5 is less than delta. Ne? So remember, always, all the time, what is our goal? Our goal is to find x minus a, which is indeed x minus 24 for now. Ne? It means we are forced to find what? To find our goal, which is x minus 24. Ne? This is our goal, to find this thing. Ne? So let's go on. So what can you do here to find x minus 24? You have to rationalize. When you are rationalizing, you are going to have square root of x plus 1 minus 5 all multiplied divided by 1 multiplied by what? Multiplied by square root of x plus 1 plus 5 all divided by square root of x plus 1 plus 5 this thing is still our absolute value of that thing less than delta. So this thing implies that what you're applying, what it means, you're going to have that all squared, which is x plus 1, since we already cancelled the square root, minus 5 squared, which is 25, divided by the square root of x plus 1 plus 5 is less than delta. Yeah? Therefore you have epsilon as what? 1 minus 25 is x minus 24. Do you see what I see now? I see my what? I see my goal. I see my goal. Do you see? I see my goal here. X minus 24 is the one that I want here. From here to here. That's my goal. Understand? So let's move on. I'm going to have what? X minus 24 multiplied by 1 over square root of x plus 1 plus 5 is less than delta. I still see my goal. I see my goal. Understand? So let's move on. This thing implies that what? Remember, this is A, this is B. The absolute value means I'm going to have the absolute value of x minus 24, the absolute value of 1 over square root of x plus 1 plus 5 is less than delta. Ne? So since, well, I want this as my goal, I have this problem thing here. I have this problem here. But I'm going to fix it. I'm going to check what's happening when we're approaching this number. What's happening with it when we're approaching this number from both sides. Yeah? So now this is your function. Your function of x plus 1 plus 5. Yeah? So we have this graph. We have the graph there. This is our 24. So we're going to check the numbers that are between 24 and what? 24 on the left and on the right. It means I'm going to have 23 here and 25 here. Understand? So if that was the graph, ne? If this was my graph like this, let me write that graph like this. If this was my graph, it means with my graph there, something the graph was going to go like this. Let me show you. The graph was going to go like this, but that graph here is discontinuous, ne? Since we cannot really approximate it, ne? Therefore we know this thing here is what? Is discontinuous. But then we wanted this thing here, some delta. We wanted it here. Understand? But we don't what? We can't. Ne? But then if we what? We check both sides, or what is between what? We can approximate it. Ne? So let's check. Let's check the function value here. Since well here is defined, what is it equal to? Here. Understand? And also here, let's check, since well here is defined, what is it equal to? So what is our what? Our interval. We know x, this 24 is between what? Is between x is greater or equal to 23 and x is less or equal to 25. It means I'm talking about what? I'm talking about this range. I mean, yeah, that range. Understand? So this thing means what? X is less or equal to 25 but greater or equal to 23. Understand? It means I'm going to check the values of f of x, which is what? Which is this function of mine here. Understand? Or what is it equal to at x equal to what? 23. And where? At x equals to what? 25. So let me substitute my values now. I'm going to have 1 over square root of what? 23 plus 1 plus 5. Meaning I'm going to have what? 1 over what? Square root of 24 plus 5. Leave it as like that. It's your function value. Ne? And x at x equals 25. Meaning I'm going to have 1 over square root of 25 plus 1 plus 5. Which is indeed equals to 1 over what? Square root of 26 plus 5. Bear in mind, if we are having a large number in the denominator, that number is big. But since, well, this is small and this one is big, square root of 26 plus 5 is bigger than square root of 24 plus 5. But if the bigger number is in the denominator, it means what? This thing is small. Let me give you an example. If I have what? If I have 1 over 1 and 1 over 2. If I dare have a bigger number in a what? In a denominator, it means my and the same numbers in the numerator, but I have the bigger number here and here. It means the one with the bigger number in the denominator is small, this one is big. Since, well, this one equals to 1, this one equals to 0.5. Understand? So here it means what? Here also means what? Means this one is what? This one is small, this one is big. It means within my range, né? Within my range. Let's talk about my range. Within my range, since, well, that thing is the y values, né? So within my range, according to me, this one is here. This is my sum delta. This one is here. Understand? So it means this one is 1 over square root of 24 plus 5. Here is 1 over square root of 25 plus 5. Understand? So it means my function, which is what? 1 over square root of x plus 1 plus 5. Ne? It's less than what, but greater than what? It's less than this. Here we want this. It's less than this. It's less than what? 1 over square root of 24 plus what? Plus 5. But greater than what? Greater than what? 1 over square root of 25 plus 5. Understand? It's correct. So since, well, the question says implies that what? Square root absolute value of x minus 24, which is my goal, x minus 24, absolute value of 1 over square root of x plus 1 plus 5 is less than delta. So between these two numbers, ne? Between these two numbers, this one, which one can I take? These numbers, which one can I take? Since, well, here is my sum delta, ne? So I want to put the value that is less than what? The biggest number. Since, well, the biggest one is true and false, ne? How? If I say if I take this one, I say it's less here, it means I'm talking about this side. If I take this one, I say it's less here, less than some delta, it means it's what? Is within this range, and is including my what? My sum delta. Which one? The one that I want. It means I'm taking that one. It means I'm going to have x minus 24, which is my goal, absolute value of what? 1 over square root of 24 plus 5 is less than what? Sum delta, ne? So I can see now, I can divide by that thing, ne? But to use something that is very quick to eliminate that, you know what I'm going to do? I'm going to say implies that absolute value of x minus 24, or you can divide by 8, is still fine. Then do a reciprocal. 24 plus 5. The only thing that I'm going to do what? I'm going to multiply by this both sides, square root of 24 plus 5, which is less than what? Square root of 24 plus 5, all multiplied by what? Multiply by some delta. I know this one cancel that one, ne? I'm going to remain with what? I'm going to remain with my goal, which I found it finally. It's less than what? That thing is 9 point, this thing here, punch it on a calculator, 9.89 multiplied by some delta. So for now, I'm going to do what? I found my goal. It means I'm going to do what? I'm going to now choose. I'm going to choose what? epsilon equals to this, always all the time, equals to 9.89 multiplied by what? Some delta. It means my mean from 1 to what? To 9.89 multiplied by some delta. So if they give you E as something, you take your E here, understand, and substitute your value there, if and only if they gave you, ne? This is how simple this chapter is. Simple and interesting. Thank you for watching.